Okay, so today we're going to cover section 3, and we're going to learn how to use or learn what a midpoint is and how to use the midpoint formula and to find the distance of a line segment. So on the first slide here, it talks about what a midpoint is. And a midpoint is a point that divides the segment into two congruent segments. So notice here I have segment JK with endpoints J and K, and M is going to be the midpoint. And the way that I know that M is the midpoint is, notice it makes it into two congruent segments. So segment JM here has a length of 3, and segment MK also has a length of 3. So this is one way that I could tell that I do have a midpoint, because it makes two congruent segments or two equal segments. Another indicator that something is a midpoint is they may have little congruency marks on each of the segments. Let me go ahead and send some attendance here real quick. Sorry, let me see if I can switch this. Okay, can you still see the iPad screen? Yes, all right. Okay, all right, here we go. So, if M is the midpoint of JK, then that would tell me that JM, which I did in green here, is equal to the MK segment. Now, you could also say that segment JM is congruent to MK. Sometimes you're going to see segments written with the line on top, and then other times they won't. So just realize that JM with a line on top and without is indicating that it's a segment. If it were referring to a line, it would have a picture of the line on top. So as soon as you are told that M is a midpoint of a segment, then you know that that midpoint here splits each of the sides into two congruent or two equal pieces. Everybody good? Now, one other thing to keep in mind, whenever we do anything in geometry, you can't assume anything from the picture. The only thing you can assume is when you see a straight line. So for example, let's say I gave you a segment and I told you this was A and this is B, the two endpoints. And let's say I put a random dot here in the middle and I put point C there. I cannot assume that C is the midpoint. The only way that I know that C is the midpoint is they're either going to have to give me congruency marks, or they might have to give me numbers and tell me that AC equals 5 and CB equals 5, and make sure that these two numbers are the same. Or they give me a statement. For example, they could say C is the midpoint of AB. So without a statement or numbers or congruency marks, I can't just assume that C looks like it's in the middle without specific facts. Does that make sense? All right, let's go on and see what a bisector is, specifically a segment bisector. So when we have a segment bisector, it's going to be either a point, a ray, a line segment, or a plane that is going to intersect the segment at its midpoint. So we have our segment, and either a point's going to go through it, array, a line segment, or a plane, and then it would split the segment into two equal pieces or two congruent pieces. So in this particular picture, it's telling us that line CD, which is here in green, is a segment bisector of segment AB. So AB is the segment, and it's been bisected by a line. So because AB was bisected, I now know that this segment here, AM, is going to be equal or congruent to MB. Because a bisector will hit it at its midpoint and make it into two congruent pieces. So you can either state that AM is congruent to MB, or you could also say AM equals MB. When you see the equal sign, then that's telling you they're talking about the exact number or the exact measure. Congruent, it just doesn't matter how long it is, we just know it's the same size. So if you're told that a line segment has been bisected, then the point at which it is bisected is going to be the midpoint. So in this particular picture, M is the midpoint. Now, keep in mind, you cannot, oh my goodness, you cannot bisect a line, array, a plane. You cannot. These cannot be bisected, but they can be bisectors. Okay, so these cannot be bisected because they go forever. How could you find the middle of a line when it doesn't have an end? Or how could you find the middle of an array if one of the endpoints goes on? And the same for a plane. Okay, so here's our first example. We have a picture of a skateboard design, and they're telling us that VW, which is right here, bisects XY. Here's XY, and it's being bisected at point T. So that should tell me that point T is going to be the midpoint. Okay, so T is the midpoint of XY. So since T is the midpoint, that now tells me that XT is equal to TY. And if you notice in the picture, they do have the congruency marks. And in the problem, they told me that XT equals 39.9. So if we know they're equal, then TY is also 39.9. So now it's asking me to find the length of XY. X is here, Y is here, so it's asking me to find the length of the whole thing. So what I need to do is, if I realize that this piece right here is 39.9 and so is this one, to find the length of the whole thing, we're just going to add the two numbers or multiply it by 2. Now, let me show you officially and how we could draw this in and get an idea of how you're going to be writing proofs. So I'm going to show you how this applies. So we're going to use our segment addition postulate, and we know that XY is equal to XT plus TY. And the reason I can state that is my segment addition postulate. The next thing I'm going to do is substitute. I know what XT and TY equal. It's this 39.9. and that's what's going to give me the length of xy. And the reason that I would put, now this is just, you don't have to do this in your homework, write down these reasons, but I just want to maybe lead you into how we're going to write proofs in the next chapter. Next, what we'll do is we're going to add 39.9 plus 39.9, and I get 79.8. And in my reasons, I'm going to say that I added. So now what we can say is the length of xy equals 79.8 centimeters. And really all you need to do when you're doing this in your homework is show me that you're adding 39.9. But I just want to give you an idea of how we're going to be writing proofs. You're going to give some kind of statement, and then you're going to provide a reason why you can say that. And that's how we write proofs. But right now in the homework, we're not doing that, but I just wanted to give you an idea of how it was set up. You're pretty good?
Almost.
Okay.
Miss Corey,
Yes.
what does SAP stand for?
Segment addition postulate.
Thank you.
You're welcome. So that's my abbreviation for it. Okay, so here they're telling us that M is the midpoint of this segment VW. It wants us to find the length of VM. So VM is right here. Now, as soon as they've told me that M is the midpoint, that tells me, and they've even added congruency marks for us, that tells me that VM is going to equal MW. So that's the information that I'm going to use. I'm going to use that VM equals MW. So I'm going to write an equation representing this. So I know that VM is equal to 4x minus 1, and MW is 3x plus 3. Now, when you're doing your homework on things like this, I need to see the equation that you're using, and then I need to see you work it out. Okay, just don't tell me that the answer to this problem is 15. So we're going to find the value of x first. So I'm going to subtract 3. Now, you can move numbers first or letters. That order doesn't matter. 4x minus 3x is x equals 3. And then I'm going to add 1. And my value of x is 4. Now, it didn't ask me to find x. It wants me to find VM. So now I'm going to take the expression that represents VM, which is 4x minus 1, and I'm going to substitute in a 4 for the x. So 4 times 4 minus 1, 16 minus 1, I get 15, which is the length of VM. So when you take tests in this class, make sure that you read what I'm asking for. Okay, I might have asked for the length of VM. I might have asked for the length of MW, or I might have even asked for the length of the whole thing, VW. So make sure you read and pay attention to what I'm asking for. Generally what happens during the school year, and it's going to happen now, is there's so many different versions of the test out there that some versions will ask for VW, some might ask for VM, and I just mix it all up. All right, let me see, somebody's trying to get in. Let's see. All right, let me let Chantal in. She had to switch. Okay. All right, everybody good so far? All right,
No, wait, can you like stay like for 3 more seconds, please?
absolutely. Can you still see my iPad screen?
Yes.
Okay, good. All right, if it ever goes away, just let me know, because things keep popping up and
Okay, thank you.
you're welcome. Anybody else still need it? All right. All right, let's go on to the midpoint formula now. So this slide shows us what the midpoint formula is. It's over here. So the coordinates of the midpoint of a segment are the average of the x coordinates and an average of the y coordinates. So here they're telling us that if point A is x1, y1, and if point B is x2, y2, then the midpoint would have this coordinates. So what we do is we take the x's of each order pair, add them, divide by 2, take the y's, add them, divide by 2. So what we're trying to find is the length of this segment right here. Now, these little ones in the order pairs, so the x1, y1, the numbers that are here, think of them like labels. And you could say, well, this one's going to be my order pair number 1, and then the ones with the little 2's, that could be order pair number 2. It doesn't matter the order of what you choose, just stay consistent. So remember, your midpoint is going to be a coordinate. It's going to be an order pair. So we're looking to find the order pair for the midpoint, and we're going to try some examples. Everybody good?
1 more second, please.
Okay. All right, so let's try to find a midpoint. So we're going to use the midpoint formula. So just to remind you, let me go ahead and write it over here at the top. Remember, we're going to do x1 plus x2 divide by 2, and then y1 plus y2 divide by 2. This is going to give us the x of the midpoint and the y of the midpoint. Remember, it's going to be an order pair or coordinate. Now, when you go to do this, it doesn't matter if r is x1, y1 or x2, y2. You can choose. You're going to get the same answer either way. So I'm going to go ahead and say this one is going to be x1, y1, and my s, I'm going to say this is x2, y2. Just to see how I plug it into the formula. So I'm going to go ahead and I'm going to get my x's. So I'm doing 1 plus 4 divide by 2. This is going to give me the x of the midpoint. I'm going to do the same thing for the y's. I'm going to take y1 plus y2 divide by 2. And that's going to give me the y of the midpoint. So let's go ahead and do the math. So for the first one, for the xm, 5 divided by 2, because 1 plus 4, and then negative 3 plus 2 is negative 1 over 2. This is the midpoint. Now, you can leave it like this, what I would do though, if I had to graph this order pair, I would change this improper fraction into a mixed number. And you could either write it as 2.5 comma negative half, or you could write it as a mixed number. If it just asks you to list the midpoint, any one of these three answers are acceptable. So if we go look at our picture, here was R, here was S, and here's the middle. And it's this order pair at 2.5 comma negative half. Okay, so watch these copying. So again, on our next slide, this time they're going to already give us the midpoint calculated. They'll give us one endpoint, and we're going to be looking for the second endpoint. We're still going to use the midpoint formula, but we're going to sort of modify it a little bit or solve for a different variable. Okay, so notice in my picture here, they've given me J's endpoint coordinates. They gave us the midpoint. We need to find K's coordinates. Now, if it's on a coordinate plane, you could figure out what this order pair is. This order pair, if you count 1, 2, 3, and then go down 1, 2, this is actually the order pair 3, negative 2. Now, we don't have a picture, or we're going to pretend like we don't have a picture. So what we're going to do is, you might get a question on the test or the quiz that just may be words without a coordinate plane. So what we're going to do is we're going to use the midpoint formula, and let me go ahead and write it again. So the midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2, and then remember, this gives us the y and the x of the midpoint. Can you still see it? Okay. All right, so now here's how we're going to set it up. I'm going to take this and set it up and make it equal to each other, and then I'm going to use this and set it equal to each other. So what I'm going to do is I'm going to label what was given to me. So M is my midpoint, so this is my XM and my YM, and then my order pair, this will be my X1, Y1. So I'm looking to find K, which is going to be X2, Y2. That's what I'm looking to find. So let's go ahead and try it. So step number 1, I need to find X2. Step number 2, I'm going to find Y2. Then I'll put them together and make them an order pair, and that will represent endpoint K. So let's go ahead and use the blue. So I'm using x1 plus x2 divided by 2 equals xm. And for the y, I'm going to do y1, y2 divided by 2, and it'll give me the y of the midpoint. So now I'm going to replace these two numbers. I have this, and I have this, and I have this, and I have this. So let's replace. So my x1 is going to be 1. Oops, I don't want highlight. So 1 plus x2 divided by 2 equals the x of the midpoint. I need to solve for this variable right here. So I need to solve this algebraic equation. First thing I'm going to do is get rid of the 2 in the denominator. So I'm going to multiply both sides by 2. And then I'm left with 1 plus x2 equals 4. Subtract 1. And the x of the second endpoint is going to be 3. And now I'm going to do the same thing for the y. My y1 is 4. I don't know y2. And the y of my midpoint is 1. I'm now going to multiply both sides by 2 to get rid of the fraction. And I'm left with 4 plus y2 equals 2. Subtract 4. And y2 equals negative 2. Again, remember, we were looking for this order pair, which was k. So now my y2 is 3, my x2 is 3, and my y2 is negative 2. So this is endpoint k. Next, we're going to learn the distance formula. You're going to be doing problems where you may not just have to plug it straight into the formula. You may have to plug it into the formula, but maybe not work right towards the midpoint. You might have to work backwards to get an answer. So again, memorize the midpoint formula, and then you're going to memorize the distance formula that's on the next slide. Because again, it could appear on the PSAT, which you'll take in October, and the SAT, and maybe even an ACT. SAT and ACT you probably won't take till you're a junior, but just realize that all of this information that you're learning could show up on those standardized tests. Anybody still need it? Good? All right, let's look at the distance formula, which is on the next slide. So whenever you want to find the distance from one endpoint to another, or it's also could be the length of the segment, we would use the distance formula. And that distance formula is here. Again, we're using those same subscripts or those same labels. So again, notice in the picture, point A is our x1, y1, and here point B is our order pair number 2, our x2, y2. So now instead of calculating the midpoint of this segment, we're trying to find out how long it is. Now, some of you may have learned this in Algebra 1 or even in pre-algebra. Another way to find the length of or the distance is to do Pythagorean theorem. But for here, all I'm going to test you on right now in this lesson is the distance formula, because we haven't officially learned Pythagorean theorem yet. Now, if your segment is vertical or horizontal, you don't need to use the distance formula. You could just subtract like we did last week, because one of the numbers in your ordered pairs is going to be repeated. But let's go ahead and try and do an example of this. We'll do 2. And then also what I'm going to do is do a few additional examples of simplifying radicals. So let's try an example of this. I'm going to go ahead and write the distance formula up at the top just so we have a quick reference. So remember, we take the ordered pairs and we're going to do x2 minus x1 squared plus y2 minus y1 squared, and the whole thing is under a square root. So before we added the x's and divided by 2, now we're subtracting and squaring. Now, I'm going to label my point A as my x1, y1, and then I'll do point B as x2, y2. It doesn't really matter. if you would have decided to label point A as x2, y2, we would still get the same answer. But let's go ahead and do it this way. So let's go ahead and replace in the formula. So my x2 is 7. 7 minus 13 squared plus 10 minus 2 squared, all under the radical. I now need to subtract, and I get negative 6 squared, 8 squared. Now I don't add first, I square first, and then I add the result. So negative 6 squared is 36, 8 squared is 64, and I'll add them, and then square root 100, and the square root of 100 is a 10. Now you probably learned in Algebra 1 that technically this square root of 100 should have been plus or minus 10. However, we don't want any negative segment lengths, so we're always going to keep the positive. Let me see, I think I have somebody trying to get in. Today has been a bad day for internet and for Zoom. Chantal, can you hear me now? Is she here? Okay, everybody good on that example? Can you still see my iPad screen? Yes? Okay, let's try the next one. Now, this one we're going to do a little differently at the end because it's not going to be a perfect square. So again, let me go ahead. I'm using the same formula that's up at the top. Again, I'm going to call this one x1, y1, this one x2, y2. So now I'm going to subtract them. So 4 minus 2 squared plus negative 1 minus 3 squared. And it's all under the square root. I'm going to subtract, and now I'll square. 2 squared is 4, negative 4 squared is 16. I'll now add. Now, I don't know if you remember, but what we're going to be doing here is we're not going to be using a calculator. So if you were to get out your calculator and hit 20 and then hit the square root button, this answer is approximately 4.5. However, we're not going to use our calculators. We're going to simplify our radicals that are not perfect squares. And the way that you do that is we're going to do a factor tree for a 20. So I'm going to figure out two numbers that will multiply to give me 20. You can either start with 2 times 10 or 4 times 5. It doesn't matter. We're going to keep breaking it down until we get prime numbers. So I'm going to do 4 times 5. I can break the 4 into 2 times 2. And now once you have all prime numbers, we're looking to make pairs. I have a pair of 2's. So once you make a pair of radicals, this becomes a perfect square. Because if you think about it, 2 times 2 is 4, and the square root of 4 is 2. So as soon as you make a pair of 2 numbers, you just take it out of the square root. Anything that doesn't pair up stays underneath its radical. So the answer to this question, instead of saying the square root of 20, you're going to say it's 2 square root 5, because you're going to leave it in simplest radical form. Pretty good? Let me do a few more examples to review breaking down square roots. And I'll do that as soon as everybody finishes this. Let me just get this in the video. All right, so I just broke down the square root of 98. I broke it into 2 times 49. 2 was prime, 49 was not. I made a pair of 7's, and I brought a 7 out. The 2 didn't have anything to pair, it stayed underneath. All right, so you're gonna turn in these notes. They're due now at the end of class. And then your homework tonight is the section 1-3 homework assignment that's on Canvas, and it's due tomorrow. Any questions?